This is my arc welder. This arc welder operates at 220 volts, although this is not necessarily standard for all welders. This one uses 220 volts. It allows for better arcing, but is not really a required thing for all welders. As you can see on the front, it has this dial to control the amperage. But why do you need to control the amperage of a weld? You need to control the amperage of a weld in order to control how intense the heat is so that it permeates further into the material that you're welding. This can also be a negative, as if you're doing something very thin, it can burn through. This is the clamp for an arc welder. It allows you to weld. This clamp allows you to hold the welding rod in multiple different ways for whatever is most comfortable for you. But what is a welding rod? A welding rod is the rod that you hold when using an arc welder to weld with. As you can see by these examples, a welding rod is a metal rod with a coating that acts as an anti-oxidation material. The numbers and letters written on the side of a welding rod are an industry standard thing that denote the abilities of the welding rod. It will tell you the tensile strength, which is how much force it can withstand once it's welded together. It will also inform you of heat level, so like what sort of amperage you need to be at, and what its ideal environment is. Like, is it good for something that will be outdoors versus something that will be indoors and won't have to withstand the outdoors environment. This is my MIG welder. This MIG welder differs from the arc welder in a few key ways. The first of which is that instead of the anti-oxidation material being on the rod, it's held in this large gas tank. Unlike the arc welder previously shown, this welder operates at 115 volt and can just plug into a regular outlet. Instead of the weld being in rod form, the weld is instead on a spool within the machine. These spools can be replaced for different ones, and that can vary in material and thickness of wire. The end of the device that allows you to weld differs greatly from that of an arc welder, as it has a button on it that controls the feed of the wire and has a nozzle at the end that has an opening to allow gas to come out to prevent oxidation. On the inside of the door that you open to change out the weld material, there is a guide for what settings to use on the welder for different gauges of metal and types of metal. On the front of the machine is a dial that controls the speed. It's just an arbitrary scale. On the front of the machine there are two switches, one that says low and high and one that says 1 and 2. These both control the amperage level for the welder, and switching between them will give you different levels of intensity, going low 1, low 2, high 1, high 2. The combination of these switches and this dial allow you to adjust the intensity of the weld. This is my welding table. There's a couple of key items in making a welding table. The first is to have these points that stick out on the sides so that you can have a point to complete the circuit to be able to weld. Typically this is like a grounding lead or something of that sort. The second key item is to have it all be one continuous metal piece in some fashion. As you can see, all these slats that go all the way across are all connected together. This is to ensure that electricity can flow through the entire thing, so that if you have a piece set anywhere on the table, you can actually weld from there. It's got gaps in between so that slag can kind of just fall. It's better to not have something quite like that so that you can actually pick up the little metal bits, but again, this was my first attempt. So one of the things I need to do is attach this winch onto the back of the trailer and onto the blade of an excavator. So I'll show how I'm going to do that. So the plan is to have this receiver mounted onto this plate that currently has this pintle hook on it, So this will go on the back of the trailer or on the excavator, and it will be mounted with this side up against a surface to give me a better surface area, as opposed to having it like on top and just having like a small area. Because like on the excavator, there's that top area that I could use, but that wouldn't be enough, or I'm not confident that it would be enough for the strength of the winch to not just pull it off. So it's going to be mounted on the back side with, again, with one of these vertically with the reinforcement on the front, and then that will be in another one of these, and then this will go on top of here, and we can insert the winch into it, or we can have the winch inserted into this and take it out from here and pick this whole part up and put it on the trailer. And the trailer is going to be about the same sort of system as that trailer, in fact, right behind the excavator. As you can see the top of it there, there's already like a receiver thing there from a previous project. We could use that, but there's nothing holding it in place. There's no pin or anything there, so it wouldn't be able to stay in place like with one of these that has the pin in it. So now we need to move the tractor. That table's not heavy, it's just awkward. Those clamp points on the sides, they're also good for handles. Okay, so the plate that the pencil hook was on has been separated. So now we've got this that I'll have to grind down. And so I've got the receiver on here just kind of as a mock-up. And so you can see that with this on here, it goes just in between these holes on either side. So that gives me a good idea that I need to grind down like all of the edges along here. And then I'll be able to weld this on. And theoretically, if I can find the trailer or the excavator or get hold of it, I'll be able to put another receiver, another one of these onto there, so that way I can have this slot into there with this on here horizontally, so that we can attach this winch. Okay, I don't know if you can hear me or not. I'm wearing my weld mask and I got this mask down here. I'm just gonna keep it on because it's a good point of view shot. I need to use this because, as I should have expected, rusty metal does not make good contact. So I need to clear a spot on here so that I can have this attached. Okay, now then. And back supported by that, so should be fine. Okay, so I know I previously said that these are good for clamping on too, but sometimes you just gotta do stuff like this. Okay, there we go. Now I should be able to start welding. Now, as previously stated, this will warp if I don't do it at diagonal points. So I gotta do that. There we go. A bit close. Okay. Now I'll do this one. I'm holding on to the cable so I've got slack so I'm not getting caught up by this trying to do it. Okay, now it seems to be on there. Okay. Not my prettiest weld. Again, get some slack and go for it. Now that the adapter portion had been fabricated, the next step is to mount the receiver onto the trailer as the excavator was at a job site. Because of the welding stuff in the garage, we couldn't back the trailer in, so we had to park it at an angle and move it with the tractor to have it close enough for the unfortunately short cables of the MIG welder to reach. Once in position, I just needed to mark out where the receiver intersects with the trailer and grind off the paint. For the receiver, this was a simple task. The same, however, could not be said for the trailer. Now that that has been done, the welding could begin. Now I got the whole winch assembly on there. I'm just gonna test with this bit of metal as this is the first test. So we hope we don't break anything. Okay, we're going. Turn that. Okay, now we're going. So it's too heavy to make the trailer tilt down. Yeah, standing on it helped. You got it. Okay. In there. Okay, we've got the excavator out in front of the garage now, so I can start preparing to weld the receiver onto the blade. We're going right around the middle part there, in between the two arms that stick out. I also need to mark with the receiver where that will go, so I know where to grind the paint off. I'll probably need to make a little part to go right along here so that it's got another little point to weld, because these are not in line as I've previously mentioned. So I need to do that and then move the MIG welder into place and we can start welding. So that will go something like this. And from here, oh, just about 3 inches. I don't know if you guys can see that or not. 3 inches. Okay, now after measuring, this piece that will go at the top of there needs to be about 3 inches long. Just a bit over, actually. So I will go ahead and mark that. Oh, hang on. Let's go ahead and mark that. Now I gotta use this as a square because the only square I can find around here is about 5 feet long, and that's not gonna work too well. I mean, it would work, it's just kind of unwieldy for something this size. The piece that I am cutting now will go on the top of the blade and act as a support for the receiver. This will replace the 3-inch long piece I made to go on the bottom. This will also allow it to be completely flush with the top of the blade and stay in place. Doing it this way will also make it easier to weld, as I don't have to reach on the inside of this very awkward to reach area of the blade. The 4 marked areas on the back of the blade indicate where the receiver is going to be attached to the blade. Once the receiver is tacked on in these 4 points, a piece of angle iron will be put on the side of the receiver to act as a reinforcement. A weld will go the entire length of the piece on both the blade and on the receiver to hold it in place. Oh, wow, there we go. Okay, that was a bit more than a tack. But it's also not holding it in place.
That rod's better.
Yeah. I didn't stop it. Stop this.
Try tacking it in a different spot.
Yeah. Oh, that's kind of ways away. Okay. Oh well.
Not getting the ground.
No, the coating didn't come off.
It seems to be holding.
Yeah. That's good.
Do you need to grind more?
Nice.
Why am I hearing a buzz over here or a spark over here?
I think it's arcing through another part to get down here.
Oh.
It might have welded itself on at a different point.
Oh, it is over here. Hold on.
Wait.
Is that gonna stay there? The metal.
Oh.
Oh yeah, that's not good.
Oh, it was... Okay, yeah, we had that at an angle and...
Yeah.
You like grade.
Yeah.
Okay. I'm gonna block the trail.
I'm gonna move, now that
Okay, evidently that's the only way we can get contact.
let me try something.